So this is another question that looks a little scary, but actually when you break it down and if you resolve all your forces properly, it's not difficult. So we've got a particle of mass km. So that P has got kmg going down. It's on a rough plane. The plane is inclined to the horizontal. We've got a force. We've got a coefficient of friction between P and the inclined plane is mu. When x equals mg, so we're saying x, this is actually mg, the particle P is in equilibrium and on the point of sliding down. Now the useful bit about this information, it tells you therefore friction acts up. So if it's on the point of sliding down, you're going to have friction, which remember we're just always going to write as mu r, sliding down. We've got our kmg, so we can write in our r like this. And then we can resolve the forces that we have. So if we resolve, so if we take the x, we can resolve it that way and that way. We've got an alternate angle there, so if that's theta, that's also theta. So we're going to have mg sine theta, because x is mg, and mg cos theta. We're going to resolve this force. This is theta. Going down the slope is always sine theta, and this is going to be kmg cos theta. And now all we're going to do, we see the word equilibrium. We've got this way equals this way. Let's do that first. So going sort of up the plane, we've got r, and that equals kmg cos theta plus mg sine theta. And what you might want to do is like put a little tick once you've dealt with some forces, just so you make sure you don't miss any. Okay, and then you can see what's left as well. So if we're going that way and that equals that way, we have going down the slope. So remember that this is going this way and this way because we're going from the top of the arrow to the bottom, so down and across. So we've got kmg sine theta, and the only other force we've not used is mg cos theta and mu r. Right, we're trying to get an expression for mu. So what we're going to do is we're going to substitute in our r. So into the second equation. So 1, 2. So we're going to put 1 into 2. So we've got kmg sine theta equals mg cos theta plus mu, lots of kmg, because we're multiplying the whole thing by it, plus mu mg sine theta. Right, now inside everything, we've got mg. So I am going to get rid of mg, 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 mg. Everything with a mu is going to go on the same side of the equation. Oh, actually, before we do that, we can see in the question we've got tan. So when we see that, we try to get there. So we know sine divided, so we know that tan theta equals sine theta over cos theta. So what I'm going to do is divide everything by cos theta. So k sine theta, sine over cos is tan, so I'm going to get k tan theta. Cos theta divided by cos theta is just going to give me 1. I've got mu k cos theta, so again, the cos theta is going to disappear. And here I'm going to get mu tan theta, because I've got sine over cos. Now I can put all my things that are not mu, well, we'll put the mu on this side, k plus tan theta. So I've just essentially rearranged it to put that side. So then this can go there. So I get k tan theta minus 1. And hopefully you can see when you divide through by that, you end up with a solution. Sorry, it's gone right into the bottom, but that's what we get there. So for part B, we want to deduce that when k equals 1, theta must be greater than 45. Okay, so let k equal 1. So let k equal 1. Then you're going to have tan theta minus 1 over 1 plus tan theta. Now we've got mu, which is our coefficient, which is our coefficient of friction. Now you can never get a negative coefficient. So we know all of that has to be greater than 0. So therefore tan theta has to be greater than 1. So then theta is greater than 45. So that second bit's quite straightforward. Even the first bit, if you got the resolving right, the rest follows.